Now, the cardiovascular system is filled with lots of different types of blood vessels. Now, each of these blood vessels is going to have slightly different jobs. They're going to, of course, be constructed slightly differently. Now, we know that the two major groups or three major groups are arteries, veins, and capillaries. Arteries are going to be blood vessels that are going to carry blood away from the heart. Veins are, of course, going to carry blood towards the heart. But this is going to place these vessels in very different sorts of environments and dealing with very different types of things. Namely, that we have a heart, this big pump that is pushing blood into arteries. And because it is pushing that blood with force through these arteries, that means we're going to have to have our arteries have the ability to deal with that force. So one of the things that we're going to see in arteries is we're going to see lots of elastic tissue. This elastic tissue is going to allow the vessel walls to kind of stretch and give so that whenever you push blood into them, that it actually has a chance to kind of give a little bit and it doesn't just break, which would be real bad. Okay. So we're going to have lots of elastic tissue in these. You'll also notice that arteries are always going to have these nice circular openings. The reason arteries are going to have circular openings is because this is basically going to equalize the pressure or equalize the force and flow through the blood vessel itself. So by having it be nice and round, things are going to move through it at a fairly constant static rate, in what we'd call laminar flow. If you change the shape much, it would actually change how the fluid moves through the tubes. So having things nice and circular means things are going to be moving nice and orderly. Okay. Now, arteries are going to start with what we call elastic arteries. These are going to be blood vessels that have lots of muscle, but they're also going to have lots and lots and lots of elastic tissue to deal with more stretch. That's because these are going to be our primary arteries. Primary arteries are going to be closer or more directly linked to the heart, which means things are moving very, 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 very quickly through them. You can think about these elastic arteries as basically like major highways. These are interstates. Cars move on interstates very, very quickly with lots and lots of force. So we have to have the ability to deal with that lots and lots of force here. So we have massive amounts of elastic tissue. Then we get down into muscular arteries. Muscular arteries are going to have, well, lots of muscle in them. The muscle here is going to allow them to constrict or dilate so that we can help regulate blood pressures. So constriction, so making it smaller, is going to increase pressure. Dilating them is going to decrease our blood pressure. So this is one of the ways that we can help regulate that. We're also going to have lots of muscle on the insides of our arterioles. Having lots of muscle on the insides of our arterioles is going to make it easier for us to regulate flow to different tissues. So we can constrict flow in some arterioles to allow to shunt additional blood into other tissues around them that may need it. Okay, but all three have these nice circular openings. Then we get into our capillaries. Capillaries, you'll notice, are only one cell layer thick. This is basically to allow nutrients to move across them very, 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 very quickly. Because remember, this is our site of gas exchange. Now, to help us deal with this and have even more area for gas exchange, capillaries are going to be found in these networks, in these little capillary beds. This gives us lots and lots and lots of surface area in order for those processes of exchange to occur. Then we're going to enter venules, which are these very, very small sized veins. You'll notice that these are going to be drawn with this kind of oval shape. This means that we don't have pressure exerting on the walls of the tissue, so we're not forcing it into that circular shape, which is going to allow that nice even flow. Instead, we don't have that pressure, so we don't have this nice circular form. Then we get up into our small to medium sized veins, and we're going to start to see some of these valves. What these valves are going to do is these valves basically prevent blood from going backwards through the blood vessel. So as blood gets pushed into or past a valve, whenever the heart then relaxes, we no longer have that push of blood trying to move things through it. It won't have a chance to fall back to where it was before. Instead, it gets caught into these little cups of the valve, and then the next little pulse of blood, it gets pushed up even further. And we're even going to be using things like skeletal muscle pumps to help us move blood through our veins because we're dealing with such low pressures. We still have valves and stuff in our larger veins, even like our superior and inferior vena cavas. So arteries are going to be arteries are going to have circular walls or circular lumens Thick muscular walls, also filled with lots of connective tissue to help us deal with lots of force. Veins are going to have kind of ovoid walls that are fairly thin. That's because they're not dealing with much pressure at all, but they will be filled with valves to make sure that we can prevent backflow. Capillaries are only one cell layer thick, so that we can have really, really fast diffusion across the membranes, but they're going to be found in big networks to make that process even easier to get us, or so that we have more surface area, or because we have more surface area.